Hello, welcome to RCHacker. My name's Mark. Today I'm going to be looking at a gigantic servo that I've built out of a printer. So you may notice a change of scenery. I'm in Australia. This is my dad's man cave. Let's show you about. And I've got some new camera equipment and stuff like that, so you will have to bear with me. All the RC stuff runs in the family. You can see these planes up here. Let's see if I can get my focus peaking working. Yeah, right. Yeah, I've got a new camera. I've got an EOS M running the stock 22mm lens and magic lantern installed, so it's got focus peaking and stuff. Run on manual. Right, so let's have a look. This is our contraption here. It is actually, or it was actually, an older scanner printer, but underneath it's pretty stock standard HP printer. Now the main thing about these printers is that they have this strip here. I don't know if you can see that. That's a linear encoder, and on here there's a little chip that basically what it does, it can detect exactly what position it is along here. And then down the bottom we have, tucked down here, there's a DC motor, and that directly drives this little pulley to move this back and forth. Now I thought I should be able to make a servo out of this, so I got a bit obsessed with this project and it took me quite a while. What I've got a KK2. I used the KK2 because it's got an LCD and everything all set up in there. Let's turn this on demo. Let's see if we can focus. Right, yeah, so that's booting up, and now I've just got a little initialization screen. If you want more information on running Arduino on the KK2, just click on the link. I'll put a link here. Now, I don't know if that text is too small, but you can see as I move this across, the numbers work. So all the counting and stuff is working. It actually knows precisely what position it is along this rail, and it is incredibly accurate. Now normally I think with the printer, the print head just goes back and forth flat out, and as it gets to whatever position it's at, the print head will squirt out its dots of ink. So that's how these are quite accurate. And they're made cheap. They don't use stepper motors because they would be too expensive. They just use a bog standard old linear motor. So we'll move on. Now if I go to my next mode, that's gone all the way over there. That's because I've got the radio off. And we'll just go to the next mode. Now this is with the PID loop and everything all set up. So let's see it working. So now if I move the control here, you can see it moves along exactly as I move the stick, just like a real servo. And now it's not very fast. I have been playing around with the speed of it but it will tend to oscillate. But if I move it, it'll move itself back as well. Not a huge amount of torque, but it works pretty good anyway. And you can see, let's see if we can see how much current we're drawing. So as we do that, you can see how much current. You can see the signal changing as it moves back and forth. You can only see the signal when it goes one way at the moment, because that's where I've only got it hooked up to one side. Alright, so just a little very quick overview of how I made this work. I've got an ESC down here. Now I started out, I just reprogrammed an ESC, a normal 3-phase one to be a 2-phase one, and then I was sending the PWM signal from the KK2 to control the speed of the motor here. But I found it wasn't fast enough response, because it's got to start and stop very, very quickly so I can get that linear accuracy. This motor is quite fast, so what I did instead, I did a bit of desoldering on this ESC. I don't know if you can see that. I pulled the main MCU off. This was a blown up one. and then I've directly wired onto the FETs there, and then reprogrammed the everything in here so it acts like a linear, well, a brushed speed controller basically. So all the code for doing the brush speed control is in here. Anyway, just to show you how much power this has got, you know, if I just run it flat out, and it's currently, you know, I'm using about 12 volts, that's the full 12 volts going to that DC motor. And you can see how fast the potential speed that you could get out of this. Now, I think I've got to work a bit more on my algorithms and stuff, but you know, that's pretty good for a linear. You know, it took me a long time to get to this, setting all the PID values and stuff. It's not easy. And if anyone wants to look at the code, this is it here. I don't know if you really want to see it, put it in the comments, but I don't think it's fit for public consumption really. It is quite a mess. Most of it's debugging code and stuff like that. And man, unless I'm going to put this on a gigantic plane, I can't really think for a use for this at the moment. Well, actually, I have made this so I can mount a camera on here, and I want to do some very slow panning work with a camera on board, sort of like time-lapse sort of panning. But I've got a little bit of a way to go yet, and this is too fast for that. I've got to replace it with another motor. I think I've got this little motor here, which has got a gearbox on it out of an old Sony camera, and I'm going to replace that, put that motor in there. So I'll be able to get a lot more torque with this and a lot more precision, like sub-millimeter precision if I do this. And also worth noting that all the electronics that I've done, it should apply equally well to this gearbox down here. Like there's another motor here, I don't know if you can see that down there, and another encoder wheel, and you could also use that as a rotational type of servo, and then there's a rod. That's the motor that feeds the paper in and out. Maybe I could use that to tilt the whole apparatus, but there you go. I hope you've found that interesting. I'm not going to do any tutorials on how to do this. Like really, it's taken me a number of days to get this actually working, and I'm really not that keen on going through everything again and writing it up. So, you know, at least you know it's possible. You got to look up the data sheets and all that sort of stuff, but really you got to be pretty dedicated if you want to make something like this. But anyway, I think that's the world's biggest linear servo. So cheers. Thanks for watching.